A very good morning, dear my students. In a previous lecture, we were discussing about the atomic radius. So here, we will talk about the variation of atomic radius. What is that? Atomic radius. First, we will talk about group. I am taking example of first group: hydrogen, lithium, sodium, potassium. There is no need to talk about the rubidium and cesium, all that. Just I am giving the example of these four elements. So I am going to erase it. There is no need to write. Its atomic number is that 1, 3, 11, 19 and so on. You can find out the atomic number of by rubidium also by the magic number. So simply erase it. And if suppose you will write the electronic configuration, you will see that it has 1, it has 2 and 1. 2, 8, 1, 2, 8, 8, 1. It has only one cell, means which one? K cell, L cell, M cell and N cell. In the case of group, when we move from top to bottom, you can see that number of cells are increasing. Number of cells are increasing from top to bottom. Hydrogen has one cell, whereas potassium has 4 cells. So you can see that suppose you will draw the electron dot structure, it has only one electron. In the case of lithium, it has 2 cells and one valence is there. In the case of sodium, it has 3 cells, 1, 2, 3 cells, and actually they are from same group. They must have same valence electron. They have one valence electron. In the case of potassium, you can see first, second, third and fourth. It has 4 cells and 1 valence electron. You know atomic radius depends on 2 factors: number of shell, and second one is that nuclear charge. Nuclear charge. When we are moving in group from top to bottom, you can see that number of cells are increases, and because of greater number of cells, attraction will decrease and size will increase. So we have discussed about the group. But in the case of period, once we talk about the period, let's take example: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. They are the elements, and their atomic number is that 3, 4, 5, 6, 7, 8, 9 and 10. They are atomic numbers. And once we draw the electronic configuration, you will get 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, 7 and lastly that 2, 8. You can see all these elements have same number of cells. All of them have 2 cells. But what is happening, once you move from left to right, nuclear charge increases. And because of greater nuclear charge, in the case of lithium, first cell, second cell. In the case of beryllium, first cell, second cell, 2 electrons. In the case of boron, 2 and 3. In the case of carbon, one I am drawing not going to draw the image of oxygen. Just I am going to write the image of fluorine. Just write that. Okay, no problem with that. It is oxygen. 1, 2, 3, 4, 5, 6. In the case of fluorine, 1, 2, 1, 2, 3, 4, 5, 6, 7. And in the case of neon, 1, 2, 3, 4, 5, 6, 7, 8. You can see when we are moving from left to right, size decreases. Why size decreases? Because of the same number of cells. But we can observe that the nuclear charge increases. And once nuclear charge increases, the attraction between the nucleus and outermost electron increases. And because of greater attraction, all valence electron will pull toward the nucleus. All valence electron will pull toward the nucleus and size will decrease. So this is the concept why atomic radius increases when we are going from top to bottom in group, and in the case of period it is decreasing because of one reason is that greater atomic nuclear charge, and because of they have same number of cell. But number of nuclear charge are increasing from one to another one, and because of that reason size decreases. Now my question is that give the answer in my mailbox, and you can give the answer in the Google chat. Which one have a greater atomic radius, hydrogen and helium, and which one have and why they have? It is a very complicated questions and tricky questions. Try to find out the answer. Thank you and have a nice day. In next class we'll talk about the metallic and non-metallic characters.